Hey everybody, Mr. Antonucci here, and in this video, we're diving into the 2025 AP Stats free response questions. Whether you've already taken the test and want to see how you did, or you're prepping for next year, this walkthrough is for you. We're going to talk through some of the key concepts, some strategies, some common mistakes, and most importantly, solve the problem for you. Jumping into number 6, the dreaded investigative task. This dealt with comparing two means, AM versus PM reading sections. Part A asked us for a conclusion based on a p-value, and you had to interpret statistical significance in the context. Part B was more conceptual, why this was not a paired design. And Part C brought in Cohen's D effect size, where you had to compute some calculations here and interpret how meaningful the result was just beyond statistical significance. And then Part D wrapped it up with a deeper dive into how variability affects size and practical importance. So let's go ahead and look at some of this. Part A, the p-value for Stephan's hypothesis was 0.002. State an appropriate conclusion at the 5% significance level for Stephan's test in the context of the investigation. Justify. So here, since the p-value of 0.002 is less than the significance level of 0.05, we would reject the null and conclude that Stephan has convincing statistical evidence that the mean reading score for all children, similar to those in the study, who would read a story at 9 a.m. is different than the mean reading score for all children, similar to those in the study who would read a story at 3 p.m. So there you have part A written out for you. In part B, we had to explain why it was appropriate for Stephan to conduct a two-sample t-test for the difference in two population means instead of a paired t-test for population mean difference. The important thing is to understand that the reading comprehension scores in this study came from two independent groups that were created using random assignment. They were volunteers, but the groups were created from random assignments. So the individuals at the 9 a.m. treatment group couldn't be paired with specific individuals in the 3 p.m. treatment group. That's why we needed to conduct a two-sample t-test for the difference in population means. Again, I'll write that out for you below. So there you have B written out. Now, Part C has a lengthy explanation of what Cohen's D coefficient is and how to calculate it and what it means. I'm not going to read all through that. We're going to jump right to the question. Part I, calculate Cohen's D coefficient for Stephan's study, show your work. So in this case, D is equal to the absolute value of 15.2 minus 17.9 divided by the square root of 4.12 squared plus 4.43 squared over 2. If you pump that into your calculator, you end up with 0.63. So all you had to do there was calculate Cohen's D coefficient, 0.63. Part 2, higher values of Cohen's D indicate greater practical importance and lower values of Cohen's D indicate less practical importance. Typically, we use the intervals listed in Table 2, right there, to help interpret the practical importance. Based on your answer to Part CI, in the information in Tables 1 and 2, describe the practical importance of Stephan's results in context. The difference of means of 2.7 that Stephan got from his study resulted in a Cohen's D value of 0.63. Since 0.63 is in that second interval there between 0.2 and 0.8, the experiment is somewhat meaningful in real life. Now you just have to write that out in a coherent sentence, and I'll type that up for you below. And there you have part 2 typed up for you. There's one more part to this question, part D. Suppose the results of Stephan's study summarized in Table 1 instead had a standard deviation for the 9 a.m. reading scores S1 and standard deviation for the 3 p.m. reading scores S2 that were both greater than 4.43. Assume the group sample sizes and the means are not changed. Would the Cohen's D coefficient in this new situation be smaller than, larger than, or the same as Cohen's D coefficient calculated in part C? Explain your answer. Well, notice how Cohen's coefficient is calculated. It's the difference in sample means divided by the pooled standard deviation. Now, both standard deviations, if we look back, were 4.12 and 4.43. Now they're saying they're both going to be greater than 4.43. Well, if both standard deviations are greater than 4.43, that's going to increase the numerator here, because you're still dividing by 2, still taking the square root, and still having the same difference in sample means. That's going to result in you dividing by a larger pooled standard deviation, which is going to then decrease the value of Cohen's d coefficient. So we would just have to write that out in a coherent statement, and I'll do that here below. So there you have it. Now, part 2, does the Cohen's d coefficient described in part D I indicate that Stefan observed difference in the means in the new situation would have more practical importance than, less practical importance than, or the same practical importance as was originally determined in part CII? Explain your answer. Well, in general, because the lower a Cohen d coefficient is, indicates lower practical importance, this is going to result in less practical importance. And that's basically what we're going to write here. So there you have it. And that ends question number 6. Now, overall, the 2025 FRQs hit all the big ideas: comparing distributions, experimental design, probability, inference, and communication. So let me know in the comments which question you found the toughest or the most interesting. And make sure you hit that like button and subscribe so you don't miss any more videos that I'm putting out. Thanks for watching, and I'll see you in the next video.